today we have done how to find the adjoint, properties of adjoint, and then inverse of a matrix. And I told you very clearly that inverse of a matrix will exist if it will be a non-singular matrix, means its determinant will not be 0. And if its determinant is 0, the inverse won't exist. We say the matrix is non-invertible. All right. Now, inverse of a matrix is adjoint A upon determinant of A. For a 2 by 2 matrix, we know how to get the inverse. Change the diagonal entries and change the sign of diagonal entries. Then we have done certain properties of inverse. And then few questions have been done. Then I told you how to find the solution of the simultaneous equations using matrix method. All right. So today, first of all, we'll do a couple of questions on this thing. Then we will move forward. So the question is, first of all, solve the following equations using matrix method. See, strictly you have to solve them using matrix method only. The equations are 2x plus 3y equals to 11 and 3x minus y equals to 7. So 2x plus 3y equals to 11 and 3x minus y equals to 7. Okay, give it a try. Quickly. So I'm doing it, then you check your answer. Fine. So the first of all, write the equations. Write the equations into matrix method. So it is 2, 3, 3 minus 1 multiplied by xy and we get 11, 7. Am I correct? Am I correct? Now, if I say this is A, this is X, this is B. So AX equals to B. That means X is what? X is A inverse into B. And what is A inverse? A inverse is adjoint A upon determinant of A into B. Now, if A is 2, 3, 3 minus 1, then what will be adjoint A? Adjoint A will be what? In 2 by 2 matrix, change the diagonal entries, minus 1, 2, and change the sign of diagonal entries. Remember this thing? What is determinant of A? That would be minus 2, minus 9, that is minus 11. So your X came out to be minus 1, minus 3, minus 3, 2, multiplied by B, that is 11, 7, divided by determinant of A, that is 11. Your X was X, Y. Execute this product. First row, first column. So minus 11, minus 21, and then minus 33 plus 14. Am I correct? Divided by 1 by 11. So this comes out to be minus of 32 and 19, 29, minus of 19. Correct? This is what? X, Y. It is 1 by 11 also. Now if you compare, this is what? minus 32 by 11 minus 19 by 11. So now if I compare, your x will be what? Minus 32 by 11 and your y will be minus of 19 by 11. Understood? Tell me. Is there anybody else getting some other answer? Hello. Is it okay?
Yes, sir.
Have a look. Anybody who wants to discuss something about this question, who might have not attended yesterday's class? Anyone? Well, that's okay.
Yes,
Now,
sir. Please revise, sir.
should I revise it? See, I will revise for a equation. See this. See this. A1x plus B1y plus C1z equals to D1. A2x plus B2y plus C2z equals to D2. And A3x plus B3y plus C3z equals to D3. So these are three equations. Now you make a matrix out of it. These are the coefficients of x, y, z. A 3 by 3 matrix is this. These are directly x, y, z. And these are the constants which were there in the right of the equation. These constants D1, D2, D3 should be in the right of equality, not in the left. Am I clear? Now let us assume this is your matrix A. This is x, this is b. So ax equals to b. Now if we pre-multiply by A inverse, then we get x is A inverse into b. What is A inverse? A inverse is adjoint A upon determinant of A into b. So x came what? Adjoint A into b divided by determinant of A. Understood?
Yes, sir.
And the same method I have applied. Now I'll do a question for all of you so that you will be in a better state to understand it. Fine. So first of all, write down the question. Solve using matrix method. Equations are 2x plus 3y minus z equals to 5. X plus y plus z equals to 6. X minus y minus z equals to minus 4. These are three equations. Okay? See very carefully. One more question. This is the last question I'm doing over this method. Then one question I expect you guys to do it. Now, first of all, the solution. Write the equations into matrix method. Okay? Write the equations into matrix form. That means there is a matrix 2, 3, minus 1, 1, 1, 1, 1, minus 1, minus 1. That should be multiplied by x, y, z. And we get 5, 6, minus 4. Got it?
Yes, sir.
5, 6, minus 4. So this is your ax equals to b. Fine. So x is what? X is A inverse into B. A inverse is what? Adjoint A upon determinant of A into B. Now, matrix A that I have 2, 3, minus 1, 1, 1, 1, 1, minus 1, minus 1. First of all, I'll make a matrix whose entries are the cofactors of this matrix. All right. So let's find the matrix first. Cofactor with respect to 2. This is gone. This is gone. This is 1, minus 1. This is plus 1. So cofactor is 0. Now, cofactor with respect to this. Ye gaya, ye gaya. Minus 1, minus 1. So it will be minus 2 and 1 minus. We will apply to it is. Then it is plus 2. Then cofactor with respect to this. This is gone. This is gone. Minus 1, minus 1. Again, minus 2. Cofactor with respect to this. Minus 3, minus 1, minus 4, and 1 minus I will apply. So it will become plus 4. Minus 2 plus 1. So it is minus 1. Minus 2, minus 3, minus 5, and 1 minus I will apply. So it will become 5. Cofactor with respect to this. 3 plus 1, 4. Cofactor with respect to this. 2 plus 1, 3, and 1 negative sign, so minus 3. And cofactor with respect to this, 2 minus 3, minus 1. Once I will check for this one also. 2 minus 1. 2 plus 1, 3, and 1 minus 7. All right. This is cofactor. Now we will run a verification. See, elements of first row, cofactors of first row, their product should give me determinant value. So 2, 0, 3 to just 6, 6 minus 2, 4. So determinant of A should be 4. Now if I check it with second row and cofactors of second row, got it? So 4 plus 5 minus 1. It came 8. There is a difference. First वाली को check करते हैं once again. This multiplied by this. So it is 2, 0, 0, 3 to the 6 and 2, 8. Yes, first is also 8. Fine. Now let's start with the third row. Elements of third row, cofactors of third row. It is 4 plus 3 plus 1. That is also 8. That means determinant of A, I am getting 8 from everywhere. All right. So the determinant is okay, as well as matrix formed by the cofactors is also okay. So adjoint A will be what? It is C transpose. So it is 0, 2, minus 2, 4, minus 1, 5, 4, minus 3, minus 1. Now, your X was adjoint A into B upon determinant of A. Adjoint A is 0, 4, 4, minus 2, 5, minus 1. What is B? 5, 6, minus 4. 5, 6, minus 4 upon determinant of A is 8. Where's the student? I did not get what you're saying. In matrix, mistake plus 3, where is it? Then now it is 1 by 8 times if I multiply first row, first column. 6 4 are 24 minus 16. 24 minus 16 will be 8. Second row, first column. 5 2 are 10 minus 6 plus 12. So 12 and 10, 22 minus 6. 22 minus 6 will be 22 minus 6, 16. Now third row, first column. So minus 10 plus 30 plus 4. 34 minus 10 will be 24. So if you divide, it will be 1, 2, 3. That means x is what? X, Y, Z. That is equals to 1, 2, 3. Implies x is 1, y is 2, and z is 3. This is your answer. Understood? Have a look. See, these kind of questions, they have very set pattern. Okay, they came in JEE mains, JEE advanced, school boards. Whenever they came, this is a way to do it. There is no other way around. Yes, just in the school exam, do take care about the minutes of the question. Like you don't make any mistake because it's prone to error. This question is too much prone to error because students generally make mistakes while calculating cofactors. Then second scope of mistake is they do not find the right determinant. So one more thing you should definitely do. I along with the question solution, I give you two hints. Ek to keep on checking determinant of A at three places, this, and this. With this, you will get a confidence, yes, you are going correct. Second, whatever the answer you got ultimately, like I got 1, 2, 3, do check this answer in the original question once. If it is satisfying or not satisfying. If it is satisfying, in matrix C, how did I get -3? See, to get -3. -3 is basically cofactor with respect to this element. So this is gone, this is gone. This is 2 and this is +1, 3. And 1 minus I will apply because its cofactor is negative of minor. So that is why it came -3. Understood now? Second thing I was telling you that after getting the solution 1, 2, 3, do check in the original equations also. Like, is 1, 2, 3 satisfying this equation? Yes. Is 1, 2, 3 satisfying this? So 1 minus 2 minus 3 minus 4. Yes. Is 1, 2, 3 satisfying this equation? 2 plus 6 minus 3. 8 minus 3, 5. Yes. So 1, 2, 3 are satisfying all the three equations, means everything is correct. Everything that you have done is completely fine. Understood? Now, write down a question and try to do it on your own. I'll give you complete 5 minutes to do it before I do it. Question is, x plus y plus z equals to 8. X minus y equals to 5. 2x plus 3z equal to 7. Alright. Solve the questions using matrix method only. Quickly, quickly. Make the matrix equation. So the matrix equation that you have made as of now must be this. 1, 1, 1, 1 minus 1, 0, 2, 0, 3 multiplied by x, y, z, that is equals to 8, 5, 7. Yes or no? Now this is your A, x equals to B. So your x is what? A inverse into B. That is adjoint A into B upon determinant of A. Fine. Now what next? Quickly tell me. Now your A is 1, 1, 1, 1 minus 1, 0, 2, 0, 3. I'll make the matrix A, which is made up of the cofactors of elements of matrix A. So with respect to 1, it is minus 3. With respect to another one, 3 minus 0, 3 and 1 minus I will apply. With respect to this, it is 2. Then with respect to this, it is 3 and 1 minus I will apply. So minus 3. With respect to this, it is 3 minus 2. 3 minus 2 is 1. Then with respect to this, 0 minus 2. So it is minus 2 and 1 minus I will apply. So it will become plus 2. 1. With respect to this, it is 0 minus 1 minus 1 and 1 minus I will apply. So it will become plus 1. And with respect to this, it is minus 1 minus 1 minus 2. Now what we will do? Anybody? What should I do after this?
Row multiplication, sir. First row in A and first row in C. Likewise, to
So
find the
we will run
determinant of
as a verification run. So determinant of A. Elements of first row, cofactors of first row. Minus 3, minus 3, minus 6, plus 2. So it will become minus 4. From the second row, cofactors of second row. Minus 3, minus 1. Again, minus 4 I'm getting. From third row and cofactors of third row, 2, 0, 3, 1, 1, minus 2. So it is 2 minus 6. It is again minus. Correct? So adjoint of A came what? C transpose. That is minus 3, 2, minus 3, 1, 2, 1, 1, minus 2. First row became first column, second row became second column, minus 3, 1, 2, and third row became third column. Now, what is x, y, z? Is adjoint A into B, that is minus 3, 1, 1, 1, 2, 2, minus 2. Multiplied by 8, 5, 7. Whole divided by determinant of A minus 4. So it is 1 by minus 4. First row, first column. So it will be minus 24, minus 15, plus 7. First row, second column. Minus 24, plus 5, plus 7. First row, third column. Minus 6, plus 16, plus 10, minus 14. So it is minus 1 by 4 times 24 minus and 8, 32, minus of 32, 24 and 12, so it became minus 12. 16 and 10, 26, 26 minus 14 is also 12. So divide by minus 4, it will become 8, 3 minus 3. So your x is 8, your y is 3, and your z should be minus 3. This should be the answer. But you won't stop here. Now you will check these solutions in the original question. And this is your x plus y plus z, addition of all three of them. 8, x minus y is 5. So 8 minus 3, 5. And 2x plus 3z is 7. So 2x is 16 plus 3z, 9. So 16 minus 9, 7. Correct है बात? Yes, anybody? Is it okay?
Yes, sir.
Yes, sir.
Now, so this is a very popular variety in boards also. And 4 or 5 marks, a stem of 4 marks either, that case study we have, or a 5 marks question in section D, that is for sure. One of them will definitely come from this particular topic. Solving system of equations. Now, solving system of equations using matrix method. Sorry, using determinant method. Now see, this method is not there in school syllabus, but we are doing it just because it is there in the JEE curriculum. All right. Now say they're asking to solve a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z is equals to d3. So it is a1x plus b1y plus c1z is d1, a2x plus b2y plus c2z is d2, a3x plus b3y plus c3z is d3. Now, if you remember, I have told you we find x as delta x by delta, y as delta y by delta, and z as delta z by delta. Remember this thing I have told you while I started with the determinants. Now, what is delta? Delta is the determinant made with the coefficients of x, y, z. So it is a1, b1, c1, a2, b2, c2, a3, b3, c3. Now delta x is what? In delta, remove the column of x, means a1, a2, a3, and in place of that, write the constants from the right side, d1, d2, d3. d1, d2, d3, b1, b2, b3, c1, c2, c3. Then delta y is, now remove the column of y, matlab b1, b2, b3, and put d1, d2, d3 against it. So a1, a2, a3, d1, d2, d3, c1, c2, c3. And delta z is a1, a2, a3, b1, b2, b3, and d1, d2, d3. Am I clear? Is it okay?
Yes, sir.
Now, since you are now aware of delta, delta x, delta y, delta z. So ये जो system of equation है, the system of equation, we call it consistent system or we call it inconsistent system. Inconsistent system means no solution. Consistent system means at least one solution. Okay. Up now in the consistent system, we again have two things: unique solution and infinite solution. See, these three system of equations, if we see them in the three-dimensional geometry, and if I see them in the three-dimensional geometry, they form three planes. And the three planes, either they will intersect at one point, fine, or they will have a common line of intersection, all three of them, like the edge of your book. Three planes are passing through it. So they are having common line. And in that case, there will be infinite number of solutions, or there is a case when there is no solution. So there is no possibility of system having two solution, three solution, five solution. So either it will be unique solution, means one solution, or it will be infinite solutions, or it will be case of no solution. So in unique solution, your delta should not be zero. If delta goes zero, solution delta is not zero, solution is unique. For infinite solution, delta zero as well as delta x, delta y, delta z is also zero. For no solution, delta zero and at least one of delta x, delta y or delta z is non-zero. Am I clear? Now, one more term we learn here, trivial solution. Trivial solution means 0, 0, 0. Means origin is a solution. So what is the mostly question asked from this thing? Say we have system of equations a1x plus b1y plus c1z equal to 0. a2x plus b2y plus c2z equals to 0. And a3x plus b3y plus c3z equal to 0. Correct? Now, this system is having 0, 0, 0 as a solution, which is very obvious. Means x equal to 0, y equal to 0, z equals to 0 is already satisfying this system. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Now the person who is setting the paper asking you, find the condition such that the system will be having non-trivial solution. Now they won't say, they will just give you three equations and then they will ask find a condition such that the system will have non-trivial solution. Now see, it is very much obvious the system is having trivial solution 0, 0, 0. That means if I try to find delta x here, so if you try to find delta x here, this entire row will go 0. And in a determinant, when one row goes 0, the value is 0. Similarly, delta y, this will go 0, and delta z, this will go 0. So that means what? The system is already having trivial solution. Now they are saying the system is having non-trivial solution, means system is having directly infinite solution. So what simply you have to do, you have to put delta equal to 0. that is A1, B1, C1, A2, B2, C2, and A3, B3, C3. Is it fine? Now, let's do a few questions. See, try this question, very simple. And this is a question from previous year JEE Mains also. Come on, give it a try quickly. D. So let's see. Somebody answered D from Thanush. This and this is system of linear. Find the following statement. If my system has infinite solution, unique solution. First of all, for the unique or infinite solutions, let's check. See, इसमें x will be what? X will be delta x by delta. And y will be delta y upon delta. Now delta is what? Determinant A, 2, 3, minus 2. For unique solution, this thing should not be 0. Okay, do one thing. Let's find the values of each one of them. So this is minus 2a minus 6. Got it? What is delta x? Delta x will be lambda mu 2 minus 2. That is minus 2 lambda minus 2 mu. That is minus 2 times lambda plus mu. And what is delta y? It is a3 lambda mu. So that is a mu minus 3 lambda. Fine. Now let's do check for one by one option. First of all, I'll check for B option. For unique solution, delta should not be 0. That means 2a plus 6 should not be 0. So a should not be minus 3. Yes or no? Now what they are saying in the B option, if a not equal to minus 3, the system has unique solution for all the values of lambda and mu. This is certainly a correct answer. Got it? Now, A option I will check for infinite solution. For infinite solution, one side delta should be 0. That means A equals to minus 3. Then delta x should be 0. That means lambda plus mu should be 0. Delta y should also be 0. That means a mu minus 3 lambda should be 0. You will put a as minus 3. So again, lambda plus mu should be 0. That means If lambda plus mu is 0, the system has infinite many solutions for a equals to -3. So Calcutta is the correct answer. A may what they are saying, if A is -3, the system has infinite solutions for all values. No, not for all values of lambda and mu. Only those values where lambda and mu will be 0. Now, for no solution, delta should be 0. And just a second, what is the condition I told you for? Delta should be 0 and at least one of delta x, delta y, delta z should be non-zero. Very good. That is the condition only. So here, what is this? For D option, delta should be 0 means A equals to -3. And at least one of delta x or delta y should not be 0 means definitely lambda plus mu should not be 0. We are getting the same condition from both of them. So this should not be 0. The system has no solution for A equals to -3. Understood? You may give your consent by raising your thumb or by opening your mouth. Yes, sir. No, sir. Others also understood? Very good. Now, go with this question. Have a look. You do. For real number alpha, if the system of linear equation has infinitely many solutions, then 1 plus alpha square is. Yes. First of all, for infinite solution, this determinant of A should be 0. If I see these equations are what? X plus alpha y plus alpha square z equals to 1. Alpha x plus y plus alpha z is also -1. Then alpha square x plus alpha y plus z is equals to 1. This is the question. Now, first of all, this delta should be 0. For infinite solutions, this delta should be 0. So doing this delta 0 means 1 alpha square, alpha 1 alpha square alpha 1. This should be 0. Let's expand it directly. So it is 1 time 1 minus alpha square minus alpha times alpha minus alpha cube plus alpha square times alpha square minus alpha square. This should be 0. So it is 1 minus alpha square plus alpha to the power 4, 0. So it is alpha to the power 4 minus 2 alpha square plus 1, 0. So that is alpha square minus 1 whole square, 0. Implies alpha square is what? 1. Implies alpha is what? Plus minus 1. Now, we will run a cross verification method. Say when alpha is 1. If alpha is 1, here all the three equations, these first and third equation will be identical, whereas the second equation will be a plane parallel to these two. Means equation will be x plus y plus z equals to 1. Second is x plus y plus z equal to minus 1. And third is x plus y plus z equals to 1. Now it is very much clear we can never get any solution from these two equations. Yes or no? Can we ever get solution from these two equations? X plus y plus z is 1, x plus y plus z equals to minus 1. That automatically means 1 equals to minus 1. So this will give us no solution, whereas in the question they are asking for infinitely many solutions. Now if I go with alpha as minus 1, your first equation will be x minus y plus z equals to 1. Second will be minus x plus y minus z equal to minus 1. And third will be x minus y plus z equal to 1. So see, these two are identical equations. This is a distinct equation from which you will certainly get infinite number of solutions. So that is why alpha answer should be minus 1 and this value should be 1. Understood my point? See, this is a IIT advanced question. So the biggest crux behind it is we should not be like dependent on the known methods only. Like here, what did I do? I checked in the by putting the value of alpha in the equations and I got to know if there will be a solution or there won't be any solution. Understood? Well, so what we have done today we have solved a 2 by 2 equation using matrix method, this one. First we have solved a 2 by 2 equation using matrix method where Ax equals to B. So X is what? A inverse into B. Then we have solved a 3 by 3 equation using matrix method, same method. Then we have solved another question using matrix method. Then I have told you how to find a solving system of linear equations in 3 variable using determinant method. So these were the 3 equations. X was delta x by delta, y by delta y by delta, and z is delta z upon delta. Now, the system of equation is called consistent or inconsistent. Consistent system means at least one solution. Inconsistent system means no solution. All right. So consistent system is further having 2 cases, unique solution or infinite solution. For unique solution, denominator delta should not be 0. For infinite solution, delta should be 0 as well as delta x, delta y, delta z should be 0. Inconsistent means for no solution, delta should be 0 and at least one of delta x, delta y, delta z should be non-zero. Then I told you there is a solution called origin, that is a trivial solution. All right. Anybody who wants to ask something, any doubt? Tell me. Well, now you revise this entire thing on your own. And in the next 2 or 3 sessions, we will practice only questions from these 2 chapters. Mostly we have covered. The rest of the, if 1 or 2 things left, we will practice them using questions only. Fine? Chaliye. Thank you so much.